Okay, 27 is a good question. It may take a little time to understand what you're reading, but it really does benefit you by reading it several times. A passenger train observes. So a passenger on a train observes. That means he's on a train that passes him moving in the opposite direction. So the bottom line is that the passengers on a train moving like this. Another train passes in this direction over here. All right. So it goes on to say a passenger observes that a train passes him moving in the opposite direction in 3 seconds, right? While if it had been moving in the same direction, right, it would have passed him in 13 seconds. That makes sense, by the way. Now, the question is, what do you need to do now? Well, you need to determine there's something unknown in the problem, and it's something about the rate of the trains. So what I'm going to claim over here, x is the rate in some kind of unit per second of the passenger's train, and y is the rate in units per second of the other train. All right? So here comes the tough part. All right, we got to get a relationship going between x and y, and these numbers are giving me. And just to remind you, the numbers are giving me are 3, and the other number is 13. All right? So let's think about it. All right? So the passenger train clearly is slower because the other train's passing it. Hope that makes sense to you. So let's take a look, and let's write this down now. So you got the rate, of the passenger's train plus the rate of the other train, and they're going to pass each other in 3 seconds. It's a combined rate, by the way. Now let's do the other one. It's going to be equal to, who's faster? The other train's faster, right? So it's going to be y minus, well, you got the other guy's train's right next to him. It's moving along too, so I got to take away his rate. It's like if you're running at 10 miles per hour and I'm running at 5 miles per hour, the rate between us is 5. All right? So that's what we're doing over there. And how long would it take there? 13. All right. Let's multiply it out, and you get 3x plus 3y equals 13y minus 13x. I want to get the x on the one side, the y's on the other. So that's going to be 16x, 10y. Right, and I got to go back and remind myself. Oh, compare the rates of the train. So let's write this down. And how do we want to write that down? I guess we could do x over y, right? Now it'd be 10 over 16. We may have to go back and read, too, to understand what these x and y mean. And that's going to be what? 5, 8. So x is to y. That's 5 is to 8. All right? And we're done. So the rates between them is 5 to 8. All right? By the way, you could write that differently, too. You could write, y to x if you want to, and that's 8 to 5. It's up to you. I don't think they really specified it, though. Compare the rates of trains. We did that. Right? We specified what the rates of trains were. That's an interesting question, I thought. Anyway, my name is Ron Bannon. This is the draft version of a text that I'm working on. It's dated from 1904. I'm sure there's errors in it. If you see something, please say something. Reach out to me. My email address is Bannon, B as in boy, the @ symbol, NNON.US. Thank you.